The idea for this talk came into life when I saw this alert on my mobile, and well, my app was down. When I opened my Heroku dashboard, basically saw this, so everything was bad. The memory was on swap. So a usual solution we might think of is basically add more memory and be fine, but it's not the point of this presentation. And I usually, well, I have seen many Rails apps where the memory is bloated. It's still 2018 and we face that problem. There are new solutions for that coming out pretty frequently. And yeah, so we'll talk about memory bloat in Rails. My name is Grodowski, and well, what we'll cover today is basically a brief introduction to how Ruby manages memory. We will see what is memory bloat, and we'll try to look at ways to triage and fix it. Hopefully there will be some time for questions. So let's start with a really quick introduction to how the GC works in Ruby. So garbage collection, according to a definition from the Ruby hacking guide, which I strongly recommend, is a language feature to automatically detect and free the memory which has become unnecessary. So for us, the programmers, it means that we don't have to care about how objects are allocated, where they are allocated, and also when and how they are freed. But like on the other hand, it's quite a heavy task for the Ruby interpreter, and I'll be mostly talking about the MRI. So if you're on JRuby, all of you'll hear today basically doesn't apply. But the MRI has a pretty difficult task to do because it has to call malloc and ask for memory from the operating system, and then decide where to place objects and how to free them. And well, the garbage collector, the GC, is responsible for doing that. So when we allocate objects, they are allocated in memory slots that are organized into heaps. Each heap is about 16 kilobytes, depending on the platform. It's 16 kilobytes for x64 architecture, so it can hold about 400 objects. And when we ask for more allocations and have free heaps available, Ruby will happily insert them for us. When we want to add more, and some of them are unnecessary, they will be freed, and so it goes. So GC is a class that represents the garbage collector. GC start is a method to run it manually, but we shouldn't really do that. And GC stat is like a gold mine of knowledge about the process. So if you're interested, look there. And what's really important, and it's important when talking about memory bloat, is how those heaps are freed and released back to the operating system. So we're going to focus on that soon. So one more thing is what does it mean that an object is unnecessary? It means that there is no path to it starting at any of the root objects we have in memory, where root objects are classes, modules, constants, and globals. If you're interested in more about GC, I would redirect you to a presentation we've had at this meetup some time ago, and I have the link in my speaker notes. So yeah. There is a statement that MRI doesn't reclaim memory back to the OS. So what goes up never goes down. And in fact, it's not true. So when I found it somewhere in some blog post, I decided to, well, reproduce it, because when we look at those graphs, we see that it really does go down sometimes, even though it's really bad here. So, yeah, let's do a short demo of that, and we'll use a probe method that basically uses PS to print out the RSS for our current PID. So the resident set size being the actual RAM usage of the process. And we'll allocate a huge number of hello world strings to a constant array and see what happens. So please bear with me. Yeah, we have our probe method. We create a temp array, and we're going to allocate a lot of things to it. Yep. The memory has gone up. That's expected. And we'll be running the GC manually to see what happens. So when we run it with the okay, now we clear the array. So we remove all the references, and the GC should do something. And it didn't. So well, let's try in a loop, an infinite loop, and print out the usage every 1000th iteration. So we see it does go down, but it's very slow. And it's slow because of few reasons. Like, first of all, when the interpreter decides to allocate a lot of memory, it doesn't make sense to actually free it immediately if it's possible, because we are probably gonna need that again pretty soon. So it's actually more effective in most cases to avoid that malloc call and, well, retain the memory for at least some time. That's why it's being slow. It's also slow because of fragmentation. So we have the memory organized into heaps. Each heap holds 400 objects. And it's my theory, so please correct me if I'm wrong, but there is no compaction in Ruby. So if we have a single object in a given heap, it probably can't be released back to the operating system. And this is really important when we are talking about memory bloat, because yeah, when it happens, it's very hard to recover from it. And now let's go to the bloat itself. What is it? First, when we start to think about it, we should try to think, how does a healthy memory usage look like for a Ruby app? And well, that's the graph of memory usage over time. It looks like a logarithm. So it grows pretty fast at the beginning and then plateaus. The initial growth is basically caused by requiring things. So we do eager loading, but eager loading doesn't load really everything at once. We are still requiring further down this graph, and here I mean external dependencies, libs, and other stuff that comes later. Later on, the curve is a little bit flatter, but it's still growing. And that's why we can't really allocate everything at the beginning in a web app, because requests, when requests start to come at our web server, they are still doing very different operations. And only when we hit all of them a certain number of times, we can be sure that, well, that's all the memory we need. And when you ask what's the target value of that, so when the line becomes flat, or almost flat, it should be it should be about 500 megs. Of course, there are different cases, but we should target for that value. So going back to that that screenshot from, which is an actual screenshot from a production environment, when we see that everything is broken, memory is in swap, so there is, in the top screenshot, it's basically constantly affecting our performance. In the bottom one, we see a huge spike that ends up in a dyno restart, so it's also really bad. So my first idea was that we have a memory leak, which was totally wrong, and we'll see why in a sec. So going back to that graph, where the RSS is represented in red, and in blue, we have the actual number of alive objects that are stored in our memory. We can see that it changes, and it's usually less than the RSS. So the gap between those two lines are basically free slots. Those are free slots that can be allocated at any time by our process when we create new objects. However, when we create more objects than there are free slots, we will be hitting our malloc limit, and what the MRI will do, it will ask the OS for more memory. So if we look at those spikes we have that are almost touching the red lines, we can imagine that they are way bigger than that, and these are the situations where our memory usage basically goes through the roof. So, so now the question is how to find them. And yeah. By the way, coming back to the faulty statement of having a memory leak, given that we have a memory leak, the actual memory usage would be going linearly upwards, because a memory leak is a quite different situation where our program allocates unnecessary references to different objects without cleaning them up, which makes the GC absolutely ineffective because the references are still there, the objects simply cannot be removed, ever. And memory leaks happen in Ruby. Like an example could be dynamic creation of symbols before symbols start to be garbage collected in Ruby 2.0, or allocations outside of the GC world in C extensions. But these are really rare. So if you think you have a memory leak, you are probably wrong. But memory bloat is a situation we are facing here. So memory bloat is basically a program attempting to allocate too many objects at once, causing further malloc calls and increasing the total heap size dramatically. So this goes further to the third part, where we'll look at different tools and ways to actually find those problems and hopefully fix them. So my first tip would be to use an APM. I hope everybody does. And New Relic is a very good tool, but I didn't find it particularly useful while debugging the problem that actually inspired me to create this presentation. But I found Scout, which I'm going to show you in a sec. By the way, if you're not willing to pay anyone for that, there are free tools like the Rack Mini Profiler, which you can successfully apply to production environments as well. And they can do similar things, but require a bit more setup. So yeah, because I was lazy, I used Scout. And that's how it looks like. And what we see here is basically something called memory bloat insights. But really it is a list of controllers and actions with, if we were able to click that, we would see a particular request like in a New Relic trace, but with different information about object allocations. But what's important here is that 500 megs on top. So when we know that our problem is narrowed down to one or a few requests, using whatever tool we decide on, what to do next, because that's still not enough to fix the problem. And now, well, these are the tools. There are more, but I just focused on those three, and they're all a little bit different. So first comes Rack Mini Profiler I already mentioned. It's a gem that helps us profile the memory usage using a web interface and print out pretty graphs. So it's like the highest layer of our debugging stack. Then we have Derailed, which is another gem created by Schneems, who is a pretty known contributor. And Derailed offers us several local benchmarks that I found particularly useful. So with Derailed, we can debug things like the startup memory our app requires, from requiring all gems from the bundle. We can also trace memory usage over time, which is particularly useful, get heap dumps, and do other cool stuff. And there is also Memory Profiler, which is a little gem that is the most useful for locally scoped debugging. And it prints out pretty comprehensive reports for a block of code, for instance, which is demoed in the middle. I hope you can see that, where we evaluate a block of code and get a pretty comprehensive report about what memory is allocated from where. So which file, which gem, which code location, etc. And if we run a Derailed benchmark locally, we can see that more or less that logarithmic curve expressed as a trace of memory samples over time. And one trick here is to always run that in production environment. It might not be easy, but it's worth trying. So the development environment of Rails changes a lot, including eager loading, caching, different dev tools we might have. So yeah, so if we can run in production. This is a request I have reproduced using Derailed in production environment by getting some data from my production database. And we can immediately see that, well, the memory is growing like crazy. So that's the thing that caused the problem, and we are flooded. So now we flooded our own laptop. And that's good news, because this benchmark is a very good starting point for further debugging. So using the tools we have introduced, we can iterate, measure the memory footprint, do some debugging using Memory Profiler, so the syntax is on the bottom, and hopefully get to that place where we have the root cause of the issue. So I won't show you a comprehensive demo today because I don't have so much time, but I'll go through just a few tips where we should look for memory bloat causes in our apps. So rule one is don't create so many objects. Really, it's that simple, but when we think about it, it gets more complicated. So where to look for places where we create many objects, or too many of them? Of course, active record. And if we think about like a simple active record call user.find with an ID, I checked it before the presentation, and it creates 35 kilobytes of allocations and almost 360 objects in development. And I quickly learned that in development, like half of those allocations come from a gem for annotating Postgres logs. So that's a reminder to do proper debugging in production environment. But well, tips for active record. Fix the n+1s, really. They are not only affecting your database performance, but they are also causing crazy numbers of useless object allocations. So, and it can lead to worse situations than poor DB performance when our whole web app stops because of that. We can also look into different considerations and choosing between includes versus joins. So includes becomes ineffective when we load too many records because it uses an array internally. So it passes an array of IDs. And if that array gets super huge, it will be really bad for the memory. And also, when we do includes, we should carefully look at what records we load and if they have any custom serialized columns. So even though we load a simple record, but active record does a select star for us, and we accidentally load a huge serialized JSON for that record, and then deserialize it with an active record serialized method, then we can, load hundreds of thousands of, for instance, strings, which are totally useless. So this leads to scoped associations, which are pretty handy because we can still use them in includes and specify which columns to select to avoid the select star issue. Of course, we should remember about using pluck whenever we can. And well, the last option is a kind of joke, but yeah, really, if we don't find a satisfying solution, we could think about writing pure SQL at least for the given problem, or if we don't use active record, then we are lucky. Next thing, offloading web processes. So web processes should be fairly long-lived, and spikes that are causing memory bloat they should be possible to move to some kind of short-lived things like rake tasks or sidekick workers, which we can kill quickly without causing pain. When we use sidekick, it's also a good idea because we can also have bloated memory in a sidekick worker. Why not? So when we do have such a situation, it's a good idea to group those bloated workers into one queue and isolate it so that it won't affect all other, less memory-hungry workers. Use count. And what I mean by that, it's a kind of temporary fix. But if we end up having a bloated endpoint in production, and we are thinking, how should I fix it quickly, because my business is going down, count may help us in preventing certain requests from even happening. And we may have one unsatisfied customer instead of all of them. So yeah, if we do a precondition to just avoid serving a certain data set because there are just too many records, well, that's a quick win. So update dependencies, that's kind of obvious, but yeah, we should really do it because Ruby has, Ruby has been continuously improving the GC over all major releases, basically. So yeah, one thing was the garbage collection of symbols. Then there was the generational GC, other stuff. So whenever we get a new version, we probably have some performance benefits. Same goes for Rails. Adequate record was introduced in 4.2, so if you are below that version, also consider updating. And yeah, Gems do have memory leaks, and there is a list on GitHub called Leaky Gems, so you can check that out. And yeah, they also have updates for memory performance, so it's worth being up to date. Final thing, be lazy. Really, don't load too much data and think about it while writing your programs. And specifically, one more lazy tip would be to use the Lazy Enumerator from Ruby. If you don't know that, I didn't. It's a pretty cool thing that costs nothing. And it's an enumerator that doesn't allocate new enumerables for each operation that we have in our probably chain of operations on enumerables. Instead, it uses a yielder structure that passes data from one enumerator to another. And basically, if we take an example with an alphabet of 4 letters, from which we try to generate random names with a contrived example, it allocates quite a lot of memory. By the way, mem is the memory probe we have used earlier. If we do it the lazy way, we can change just one thing and be way more effective with how we allocate the memory. Well, the performance is a little bit worse, but I think it could be neglected here. So these are all the things. I hope you learned at least one useful. You got at least one useful advice from that presentation, and I wish you luck in your next hunt for bloat. Otherwise, if you know everything, it could be a good starting point to dig into GC tuning, which I didn't cover, heap dumps, which I didn't cover, and other interesting stuff with Ruby memory management. By the way, you can find me online under these handles. And yeah, my name is Jan. At daytime, I help Rainforest QA build a scalable QA solution, which is distributed and works nicely with your continuous deployment. So feel free to look at that. We're also hiring, so if you're looking for a new programming gig, feel free to chat with me. And yeah, thank you very much. That's all.